the moment humanity looked up and never looked back. For most of human history, the sky was not a place to explore, it was a place to obey. The stars were perfect, the heavens were unchanging, and Earth sat motionless at the center of everything. That was not an opinion, it was law. Then, in the early 1600s, one man aimed a simple tube of glass toward the night sky and shattered 1,000 years of belief. His name was Galileo Galilei. Galileo did not discover new stars. He discovered that we were wrong. When he looked through his telescope, he didn't see divine perfection. He saw mountains on the moon. He saw moons orbiting Jupiter. He saw a universe that did not revolve around Earth. What Galileo saw was not just revolutionary, it was dangerous, because in Galileo's world, truth did not belong to observation, it belonged to authority. This is the story of how a telescope became the most powerful weapon science has ever known, and why Galileo dared to point it at the sky. The world before Galileo looked through a telescope. Before Galileo ever touched a telescope, the universe already had an answer, and that answer was not open for debate. For centuries, people believed the cosmos was perfect, ordered, and complete. The Earth stood motionless at the center, while the sun, moon, planets, and stars revolved around it in flawless paths. This was not just a belief, it was the foundation of education, religion, and authority. A universe decided by philosophy. The dominant worldview came from Aristotle, whose ideas shaped science for nearly 2,000 years. According to Aristotle, the heavens were perfect and unchanging. Everything beyond the moon was made of a divine substance. Circles were the only perfect motion. Imperfection belonged to Earth. The sky belonged to the divine. Later, Claudius Ptolemy refined this idea into a mathematical system. His geocentric model explained planetary motion well enough to predict eclipses and calendar dates. It was complex, full of loops and corrections, but it worked, and because it worked, no one felt the need to question it. Why nobody challenged the sky? There was one major reason people didn't challenge these ideas. They had no tools to do so. The naked human eye cannot see mountains on the moon, moons orbiting other planets, phases of distant worlds. To the unaided eye, the moon looked smooth. The planets looked like wandering lights. The stars looked fixed and eternal. The sky appeared perfect because humans could not see its flaws. Knowledge came from authority, not evidence. In Galileo's time, science was not experimental. Knowledge came from ancient texts, religious teachings, and philosophical logic. If Aristotle wrote it, it was true. If the church accepted it, it was settled. Observation was considered unreliable. Human senses could deceive. Books did not. Why the church cared about the cosmos? The church did not invent the Earth-centered universe, but it adopted it because it fit theology. If Earth was at the center, humanity was central to creation. If the heavens were perfect, God's design was unquestionable. Change the structure of the universe, and you changed humanity's place in it. That was not a scientific issue. It was a political and religious one. Questioning the sky was dangerous. To challenge the heavens was to challenge authority, and authority did not respond kindly. Questioning cosmic order could mean accusations of heresy, loss of reputation, legal punishment. So most people didn't ask, "Is this true?" They asked, "Who said this first?" Galileo's world was ready and not ready. By the late 1500s, Europe was changing. Navigation demanded better astronomy, mathematics was advancing, curiosity was growing, but belief was still stronger than evidence. Galileo Galilei was born into this world.
A world where the sky was already explained. A world where looking too closely could be more dangerous than not looking at all. And yet, Galileo would look.
Galileo did not invent the telescope. One of the most common beliefs in science history is also one of the most wrong. Galileo did not invent the telescope. The telescope was not born in Italy, it was born in the Netherlands. The Dutch spyglass. In 1608, spectacle makers in Holland began experimenting with lenses. One name stands out: Hans Lippershey. Lippershey discovered that placing a convex and concave lens together could magnify distant objects. The device was simple, crude, but powerful. It allowed soldiers to see enemies from far away, merchants to spot ships early, governments to gain advantage. It was called a spyglass. News travels faster than invention. Word of the spyglass spread quickly across Europe. There were no patents protecting the idea, no secret blueprints, just rumors, descriptions, stories. By 1609, news of a tube that makes distant things appear closer reached Italy, and it reached Galileo. Why Galileo cared? Galileo immediately understood something others did not. This device was not just useful for war, it was useful for the sky. While most saw military advantage, Galileo saw scientific revolution. He did not ask, "How can I sell this?" He asked, "What happens if I point it upward?" Galileo builds his own telescope. Galileo never saw a Dutch telescope. He only heard descriptions. Using his knowledge of optics, he built his own version from scratch. His first telescope magnified 3 times. Within weeks, he improved it to 8 times, then 20 times. No one in Europe had anything like it. Improvement was the real invention. Galileo's genius was not the idea of the telescope, it was what he did with it. He refined lenses, he reduced distortion, he increased clarity. Most importantly, he made the telescope reliable, a scientific instrument, not a toy. Why this matters? Others had spyglasses, but Galileo was the first to use a telescope systematically to study nature. He took careful notes, he repeated observations, he compared results. This was something new. The moment everything changed. In late 1609, Galileo aimed his telescope at the moon, and what he saw would make the old universe impossible to defend. The telescope did not invent new objects, it revealed flaws in what humans thought was perfect. A dangerous choice. Galileo could have used the telescope for wealth or power. Instead, he chose truth. He chose to publish what he saw. That choice would bring him fame and enemies, and it would change humanity's relationship with the universe forever. Why Galileo pointed the telescope at the sky. When Galileo built his telescope, he had a choice. He could use it the way everyone else did, for war, for profit, for political favor. Most early telescopes were pointed toward the horizon, not the heavens. A tool for power or truth. In the early 1600s, Italy was divided into competing states. Military advantage mattered. A telescope that could spot ships or armies early was extremely valuable. Galileo knew this. In fact, he demonstrated his telescope to the Venetian Senate as a military instrument. The reaction was immediate. Venice rewarded him with money and job security. But Galileo was not satisfied. Galileo's deeper curiosity. Galileo had always believed that nature must be studied directly, not through ancient texts, not through tradition, but through observation. The telescope gave him something no philosopher had ever had before, a way to test ideas against reality. And the greatest test was the sky itself. the risk of looking up. Pointing the telescope at the sky was not a neutral act. It was a challenge. The heavens were sacred, perfect, untouchable. Looking too closely meant risking contradiction. Galileo knew this, but curiosity outweighed fear. The first night observations. In late 1609, Galileo aimed his telescope at the moon. What he expected to see was smooth perfection. What he actually saw was shadow, light, and darkness. Mountains on the moon. As the moon's surface shifted with phases, Galileo noticed something impossible. Shadows changed, edges were uneven. This meant only one thing: the moon had mountains, just like Earth. That observation alone destroyed the idea of a perfect sky. A sky like Earth. If the moon was imperfect, then the heavens were not divine. They were physical, material, subject to the same rules as Earth. This was not a small correction. It was a collapse of an entire worldview. Galileo's choice. At that moment, Galileo could have stopped. He could have said nothing. He could have used the telescope only for safe demonstrations. Instead, he kept going. He turned the telescope toward the planets, toward Jupiter, toward Venus, and with each observation, the old universe cracked further. Why Galileo didn't look away. Galileo understood something fundamental. If observation contradicts belief, belief must change. That idea was revolutionary and dangerous. But Galileo believed truth was not fragile. It could survive being seen. The telescope was no longer a device. It was a challenge to authority itself. What Galileo saw that changed everything. When Galileo continued turning his telescope skyward, the universe began to unravel. Not slowly, not gently, but all at once. The moon was not perfect. Galileo's first shocking discovery was also the simplest. The moon was not smooth. Through his telescope, Galileo saw mountains, valleys, and craters. Light and shadow moved across its surface as the moon changed phases. That could only mean one thing. The moon was a world, not a perfect celestial object, but a physical body like Earth. This alone destroyed the ancient belief that the heavens were flawless. But Galileo didn't stop there. Jupiter's moons, the fatal blow. In January 1610, Galileo turned his telescope toward Jupiter. What he saw confused him at first. Small points of light lined up near the planet. Night after night, their positions changed. At first, Galileo thought they were stars, but stars don't orbit planets. These lights did. Galileo had discovered 4 moons orbiting Jupiter. This was catastrophic for the Earth-centered universe because it proved something undeniable. Not everything revolved around Earth. Here was a planet with its own system, a miniature universe in motion. Venus and the death of geocentrism. Galileo's next discovery was even more dangerous. He observed Venus over time and noticed it went through phases, just like the moon. This could only happen if Venus orbited the Sun. There was no way to explain this under the Earth-centered model. The evidence was clear. The planets did not circle Earth. They circled the Sun. The Sun was not perfect either. Galileo then did something few dared to do. He studied the Sun. Using safe methods, he observed dark spots moving across its surface. Sunspots. The Sun was changing, rotating, imperfect.
Even the sun was not divine. A shattered sky. Each discovery was devastating on its own. Together, they were impossible to ignore. The universe was not centered on Earth. The heavens were not perfect. Motion was complex and dynamic. Galileo had not merely adjusted old theories, he had replaced them with observation. Why this was so dangerous? Galileo's discoveries didn't just challenge science, they challenged authority. If ancient philosophers were wrong, if church-approved models were wrong, then truth did not come from books, it came from nature, and anyone with the tools could see it. That idea was explosive, because once people trusted observation, no authority could fully control knowledge again. Galileo published his findings. He did not hide them. And in doing so, he set the stage for the greatest conflict of his life.
Why Galileo's discoveries were dangerous. Galileo's telescope did more than reveal new objects in the sky. It exposed a problem no one was prepared to face. What if the universe did not match the beliefs that governed society? Knowledge was power. In Galileo's time, knowledge was tightly controlled. Universities taught approved ideas. Religious institutions defined truth. Ancient authorities shaped reality. This system worked only if people trusted it. Galileo's discoveries threatened that trust. The problem was not the telescope. Contrary to popular belief, the Church did not immediately reject the telescope. In fact, many clergy looked through it themselves. They saw the moon's surface. They saw Jupiter's moons. The problem was not what Galileo saw. The problem was what it meant. Earth was no longer special. If Earth was not the center, humanity was no longer the focus of creation. This raised dangerous questions. If Scripture and nature disagreed, which one was wrong? Galileo believed Scripture taught how to go to heaven, not how the heavens go. But this distinction was unacceptable to many authorities. Observation versus authority. Galileo argued that nature could not lie. If observation contradicted tradition, tradition must be reconsidered. This idea undermines centuries of intellectual hierarchy. Anyone with a telescope could challenge philosophers. Anyone with evidence could challenge doctrine. Why Galileo couldn't stay silent? Galileo was warned to present his findings carefully, privately, hypothetically. But Galileo believed truth deserved a voice. He wrote in Italian, not Latin. That meant common people could read his work. This widened his influence and his enemies. The Copernican line. The heliocentric model had existed before Galileo. Copernicus proposed it decades earlier, but Copernicus lacked proof. Galileo provided it, and proof made belief dangerous. The fear of disorder. Authorities feared that questioning the cosmos would lead to questioning everything: government, religion, law. If Earth wasn't central, why should human institutions be? Galileo's telescope was seen as a threat to order, not because it was wrong, but because it worked. The line is crossed. Eventually, Galileo was told to stop teaching heliocentrism as fact. He was allowed to discuss it only as a mathematical idea. For a time, he complied, but Galileo was convinced the universe he saw was real, and silence felt like betrayal. The conflict was no longer avoidable. The stage was set for a confrontation that would define the relationship between science and authority forever. Galileo on trial, when science faced power. By the early 1630s, Galileo had become too visible to ignore. His ideas had spread beyond universities, beyond scholars. They were being discussed by ordinary people, and that was the problem. A careful warning and a risky return. Years earlier, Galileo had been warned by church authorities. He was told not to teach heliocentrism as physical truth, only as a mathematical possibility. For a time, Galileo obeyed, but he never stopped believing what he had seen. The book that changed everything. In 1632, Galileo published a book that would seal his fate. Dialogue concerning the two chief world systems. It was written as a conversation between three characters. One defended Earth-centered ideas, one defended the Sun-centered universe, the third asked questions. Galileo claimed neutrality, but the message was clear. The heliocentric system was superior, and the defender of geocentrism appeared foolish. Rome takes notice. The book spread quickly, and with it, Galileo's influence. Church authorities were furious. They believed Galileo had crossed a line, not by observing, but by persuading. The trial begins. In 1633, Galileo was summoned to Rome. He was 68 years old, ill, weak. He faced the Inquisition. This was not a scientific debate. It was a trial of obedience. The charges. Galileo was accused of disobeying earlier warnings, teaching forbidden doctrine, and undermining authority. Evidence from his telescope was irrelevant. The question was not whether heliocentrism was true. The question was whether Galileo had the right to say it was. The choice Galileo faced. He was threatened with imprisonment, possibly torture. He was shown instruments of fear. He was pressured to recant, and Galileo made a decision that would haunt him forever. The recantation. Galileo publicly denied that the Earth moved. He declared the sun-centered universe false, not because he believed it, but because survival demanded it. Legend says he muttered, "And yet it moves." Whether he did or not, the truth remained. The sentence. Galileo was found guilty. He was sentenced to life under house arrest. His books were banned. His voice was silenced, but his ideas were not. A victory that wasn't. The church believed it had won. Galileo was quiet, but the telescope still existed. The evidence still existed. And once seen, the universe could not be unseen. Science had been wounded, but it had not been defeated. How Galileo changed science forever. Galileo was silenced, but the universe was not. Under house arrest, Galileo could no longer teach publicly. He could no longer publish freely. But the damage to the old way of thinking was already done. The telescope could not be uninvented. Galileo's greatest legacy was not a discovery, it was a method. He proved that nature must be studied by looking, not by quoting. Once people accepted that idea, authority lost its monopoly on truth. Anyone with the right tools and careful observation could challenge ancient beliefs. Observation became more powerful than belief. Before Galileo, science asked, "What did the great thinkers say?" After Galileo, science asked, "What does nature show us?" This shift was irreversible. It became the foundation of the scientific method. Observation, measurement, experiment, repeatability. These principles define science today. A new relationship with the universe. Galileo's telescope changed how humans saw the sky. The universe was no longer distant and divine. It was physical, accessible, understandable. Mountains on the moon meant other worlds were like Earth. Moons around Jupiter meant Earth was not unique. The universe suddenly felt larger, and humanity felt smaller. The spread of the telescope. Despite Galileo's punishment, telescopes spread rapidly.
astronomers across Europe confirmed his observations. They saw lunar mountains, Jupiter's moons, planetary phases. Truth multiplied, and no single authority could stop it. Galileo's ideas outlived his sentence. Galileo remained under house arrest until his death in 1642, but his work continued to influence Isaac Newton, Johannes Kepler, and modern astronomy. Newton's laws, which would later explain planetary motion, rested on Galileo's foundation. A delayed apology. Centuries later, the institution that condemned Galileo revisited the case. In 1992, the Catholic Church formally acknowledged that Galileo had been right. The Earth does move. The apology came late, but the truth had never waited. Why Galileo still matters today. Every space telescope, every planetary mission, every image of distant galaxies all trace back to Galileo's decision to look for himself. He taught humanity that curiosity is not a crime, that evidence matters, and that understanding the universe requires courage. The cost of truth. Galileo paid a heavy price. He lost freedom, he lost status, he lost his voice. But humanity gained something greater, a new way of knowing. And once that way existed, it could never be taken away.
The telescope that changed humanity. When Galileo was forced into silence, the universe did not return to how it was. Something irreversible had happened. Humanity had learned that the sky could be questioned. And once a question is asked, it never fully disappears. A simple tube of glass. Galileo's telescope was not large. It was not powerful by modern standards. By today's measure, it was crude. And yet, it did something no invention had ever done before. It removed humanity from the center of the universe. Losing the center, gaining perspective. Before Galileo, Earth was the focus of everything. After Galileo, Earth became one world among many. That realization was uncomfortable, but it was also liberating, because if Earth was not special by position, it could be special by what it became: life, curiosity, understanding. The birth of a new way of thinking. Galileo didn't just change astronomy, he changed how truth was found. From that moment on, evidence mattered more than tradition. Observation mattered more than authority. Questions mattered more than obedience. This shift reshaped everything: medicine, physics, engineering, space exploration. Every scientific breakthrough since rests on that foundation. From Galileo to the stars. Every telescope that followed is a descendant of Galileo's first one. From mountaintop observatories to space telescopes orbiting Earth, we are still doing what Galileo did, pointing instruments at the sky and asking, what is really there? The cost was high, but the impact was greater. Galileo lost his freedom, but humanity gained vision. He was silenced, but truth learned how to speak without permission. No trial could put the universe back into ignorance. Why this story still matters. Today, we live in an age of information, and yet the lesson of Galileo is more relevant than ever. Belief is powerful, but evidence is stronger. Authority can demand silence, but reality does not obey commands. The final look through the telescope. When Galileo looked into the sky, he didn't know what he would find. He only knew that not looking was no longer acceptable. That decision changed everything, not because he was the first to wonder, but because he was brave enough to look.